Welcome back. Guess what? Another node voltage problem. And here it's more practice. It's also meant to show that there's a little bit of flexibility in the method. All right? That is, if you choose the nodes, well, I don't want to say wrong, but if you choose them not optimally, that it'll still work. Okay? That's part of the message. And also, I don't know, just trying to get you to think a little bit more, I don't know, flexibly. But if you watched the last video, I was talking about how you need to think algorithmically, which you do in the modern age with all these computers and whatnot. But it's also a good skill to learn how to think a little more flexibly. I mean, I guess that's the more classical engineering way of thinking about things, creatively and flexibly and whatnot. But we also got the computers out there, and computers like algorithms. They like rigid sort of step-by-step thinking, although the creativity is important as well. Alrighty, you need both, is the conclusion. Yeah? So look, we're given this thing, and we're asked to find. So we're asked to find V1, which is measured across here. Okay, kind of in the middle of these two guys. But in this problem, we're given V1 and V2 nodes, and we're given the 0 node here. So this is the flexibility part. So this guy right here is not set up as a node voltage node. It's a node, but it's not part of the node voltage equations, right? We just have V1 and V2 as the node voltage system of equations. Technically, you really should throw this in here as, say, V3. You should, but we're not going to do that. We're just, that's the thing. Like, we're trying. Like, what happens if you don't label all the nodes? Are you screwed? And the answer is, no, you're not really screwed. You can still find it. All right, and that's what we're asked to find is V. That's it. Okay, so once again, what happens if you don't declare this as an official, officially approved, whatever, node voltage node? It'll still work. Okay, so let's show you. So we've got our convention is in is going to be negative and out is going to be positive. I like to write that out because sometimes I'll forget, So we've got, this is going to come out pretty quick, NV1, node voltage 1, this is this guy. So we've got, this is 4.5 coming in. And then let's throw some arrows on here. This is going to split, this current, it's going to split and go that way. And then it's going to come along here. And, here's where we, here's where we got to make some guesses on what's happening on the current here. So I've got a positive terminal here. And in circuits, the world of circuits, current comes out of the positive terminal, which, by the way, it doesn't really. Physics speaking, it comes out of the negative terminal. But, in circuits, I don't want to confuse you, but in circuits, we always assume that the current's coming out of the positive terminal. Okay, that's worth dwelling on for a moment. The reason it's like that is because when they started making these circuit things, they didn't know. They didn't know that electrons were negative. So, what's really happening in the physics is all of this is backwards. That the current is coming out of the negative terminal, and everything's running backwards. Like in your car, the negative ground in your car, it's actually the source of all the electrons, and they're actually running backwards and heading back to positive. So it doesn't matter. Everything works fine as long as you're consistent, and we've built the entire world assuming the positive circuit convention, and it's fine, it works. But in reality, the physics, everything's going backwards. It's a trip, huh? So anyway, I'm guessing that the current's coming this way, and if I got a current coming into V2 here and a current coming into V2 here, it's got to get out somehow, so I'm going to guess coming down that way. Okay, now we can write these things. So V1 I've got in, which is negative 4.5 volts or amps. Okay, and then this current here coming out, it's out, so it's positive. It's going to be V1 over 1 by Ohm's law. This guy coming out okay? It's out, so it's positive, and the term is going to be, well, it's the potential difference, right? It's V1 minus V2. You put the V1 on the left because that would give you a higher potential on the left, which makes the current go to the right, over 6 plus 2. Okay, that's the potential difference between these two nodes and the total resistance between those two nodes. That's all the ins and outs of node 1. So those sum to 0. And then we can write node voltage 2. We can do this again. So this one coming into this node, it's this current here. It's the same current, so it's coming in this time, but it's the same term. So it's V1 minus V2 over 6 plus 2, but just with a negative sign because it's coming into this node. And then also coming into this node is this guy here. So here's a little trick for you guys. So if this is 0 volts because it's on the bottom, then as we go through this voltage device, it's raising the voltage by 30 volts. So this is a node that has a known voltage. So you don't need a variable for it. You can just throw the known term on there. Okay, then we can write an expression for this current right here. So so we're trying to write a node voltage 2. We've got in coming in. We've got this other in coming in, which is going to be it's going to be negative because it's coming in, and the potential difference is 30 minus V2 over 4. That's that guy. And then this guy coming out, this one here coming out, is positive, and by Ohm's law it's V2 over 12. Those sum to 0. So if you you count the unknowns and the equations, I got 2 equations, 2 unknowns. There's a solution. So let me write that out for documentation. There's 2 EQs, 2 unknowns. Therefore, there's a solution. This is just documentation that you can read without having to rethink through the whole problem, right? So we put in standard form so that we can solve it with a computer. If you put these two in standard form, you're going to end up with these 2 equations. The NV1 is going to be V1. You end up with, if you factor out all the V1 and collect all the numbers, you're going to get 1.125. And then V2 is going to give you minus 0.125. And those equal to 4.5. That's this first equation, just putting it in standard form. And then doing the same with the second equation, NV2. You get V1 minus 0.125 plus V2 0.458, and those sum to 7.5. Okay, then my computer says V1 equals 6 and V2 equals 18. That's I'm going to put that in a dotted box. It's not the final solution, but it's an important thing. Okay, that's what node voltage gives us, because that's how we set up our nodes at the beginning. We get V1 and V2, but we're really asked to find V. Okay, now we could have solved this with declaring this as V3. Then we'd have 3 equations, 3 unknowns, and V3 would just fall out, which is what we want. But this is just showing you that if you didn't do that, everything would be cool. All right, how are we going to get V here? Well, we got to do it the hard way. So, look, if we had this current, if we had the current through this 2 ohm, in other words, this, if we had this voltage drop down to 0 volts here, from this point down to 0 volts, that's the voltage we're interested in. And this V voltage is dropping. Well, some of it's dropping across this resistor here. I can throw a sign on there because the current's going through this thing. Here's the sign, and then some of it's dropping through this. So I'll throw a sign on that, aligning up with the the current direction. The voltage drop is agreeing with the current direction for resistor. Right? So if I had this current, I could use Ohm's law and get this voltage drop. And if I had this current, I could use Ohm's law and get this voltage drop. And then if I added those two voltage drops, I'd have V. So let's solve these guys. Let's call this I, so we can write some you know, some equations. So here, let me just let me just document what I'm doing. To find V, you know, find voltage drops across the 2 ohm and the 12 ohm resistors. And this guy here, I can use Ohm's law with I. And this here, this is just V2. I was saying just moments ago that if I had this current through here, I could use Ohm's law to figure out this voltage drop. But I don't even need to do that because I have V2, and that is the voltage drop across this. So, yeah, so I is, well, we have that expression. We have an expression for I up here, right? There's I. Here's that expression. So I is V1 minus V2 over 6 plus 2, which we have. This is 6 minus 18 over 8. So it's minus 1.5 amps. I'll draw a double underline. So we guessed wrong, right? This arrow direction, which was a guess, it's actually going the other way. The current's going the other way. Okay. So now we can sum the voltages at the two, you know, from the 2 ohm and the 12 ohm. And you're going to get V is the sum of those two voltages. So V is, it's 2I plus V2, right? It's using the signs that I've got here, the plus minus. It's 2I by Ohm's law, and then V2, right? 2I and V2. Just using the plus minus, those sum to V, right? Plus minus, right? There's a drop here from plus to minus, and then a drop here from plus to minus. That gives you V with a drop from plus to minus. And then put the numbers in. So this is 2, and it's minus 1.5 because the current is actually going the other direction. But you just stick with the arrow. You stick with the arrow current direction that you started with, and the positive signs you started with, and just use the negative number all the way through. What is V2? Where is it? 18, right? So this is 15 volts, and that's the answer. So now this may freak you out. You might not like that. I don't like it, but if it really bothers you, then start over and work the problem with I going the other direction, right? Just start over with I going the other direction, and then these signs will be flipped, and work it that way. And there's still a little bit of confusion in that method as well, because of this drop here, this sign's going to be reversed and stuff. So there is just inherent confusion in these, and just deal with it. I've been doing these for years. I still get confused on negative signs. Anyway, that's the method. Hope you enjoyed that. Hope that was useful to you. See you next time. Bye.